All right, buckle up, because tonight we're launching into the cosmos. We're doing a deep dive on the top 10 brightest stars we can see from Earth.
And we've got a fascinating guide for our journey. The top 10 brightest stars in the Milky Way. A journey through the night sky.
Exactly. So we're talking about those stars that really grab your attention. But, it's not just about being flashy.
Right, a star's brightness tells us a lot about what's going on behind the scenes, literally. Like, how big is it? How hot is it? What stage of life is it in?
It's like deciphering a cosmic code.
Hmm.
Okay, so let's kick things off with the star that needs no introduction, Sirius. The dog star. It's that super bright, almost blue-white star that's impossible to miss on a clear winter night.
It's definitely a showstopper, and it's been captivating people for centuries.
Oh, absolutely. Ancient Egyptians were obsessed with Sirius. They even based their calendar and agriculture around it.
And for good reason. Sirius is incredibly bright, partly because it's relatively close to us, at least in cosmic terms, just 8.6 light years away, but it's also inherently powerful.
In what way?
Sirius is actually much bigger and hotter than our sun, which means it pumps out a lot more energy.
So it's like the star equivalent of a booming voice everyone knows when Sirius is around. But here's something I always found cool. Sirius isn't just one star, is it?
You're right. Sirius is what we call a binary system. It has a much fainter companion star, a white dwarf called Sirius B.
Okay, time for a quick side note. What exactly is a white dwarf? I mean, it sounds kind of small.
Its eye small, at least compared to a star like our sun. Think about the size of Earth, crammed into something incredibly dense.
Wait, the size of Earth? How dense are we talking?
Imagine a teaspoon of white dwarf material. It would weigh tons.
Okay, that is just mind-boggling.
It's what happens when a star like our sun runs out of fuel and collapses in on itself. So in a way, we're seeing the very distant future of our own solar system when we look at Sirius B.
Okay, that is both cool and terrifying. All right, let's shift gears to a star I'm not as familiar with, Canopus. I've heard it's a big deal in the Southern Hemisphere.
It is. Canopus is the second brightest star we can see from Earth. It's so bright and consistent, in fact, that it's used by spacecraft for navigation.
Really? Spacecrafters using a star to find their way? That's incredible.
It's like a celestial lighthouse, guiding them across vast cosmic distances. And that's because Canopus is a supergiant star.
Supergiant. Okay, break that down for me.
Imagine a star vastly larger and hotter than our sun. That's Canopus. It's about 310 light years away, so much further than Sirius, but its sheer size and energy output make it incredibly bright.
So even though it's farther away than Sirius, it's still used for navigation. That's pretty impressive.
Exactly. It's intrinsically brighter than Sirius, even if it appears slightly dimmer to us because of the distance.
Okay, so it's like the friend who's quietly brilliant. They don't need to shout to be heard. All right, let's move on to a star system that's been in the news a lot lately. Alpha Centauri. It's our closest stellar neighbor, right?
That's right. Alpha Centauri is just a little over 4 light years away. And it's not just one star, but a system of 3 stars orbiting each other.
3 stars. Wow. And I remember hearing something about Alpha Centauri having a planet that could potentially support life. Is that right?
You're thinking about Proxima Centauri b, which orbits the star Proxima Centauri. And that's actually one of the 3 stars in the Alpha Centauri system.
So we've got 3 stars and at least one planet that's got scientists buzzing. What are the chances? So what are the other 2 stars in the system like?
Well, we've got Alpha Centauri A, which is very similar to our sun in size and temperature. And then there's Alpha Centauri B, a bit smaller and cooler.
So it's like a cosmic comparison study happening right next door. Okay, next up we have Arcturus, a star I've always loved because of its color. It's that beautiful orange-red that always makes me think of autumn.
Arcturus is a red giant star, which explains that distinctive hue. It's cooler than our sun, but much larger.
So it's like the wise elder of the neighborhood, a little cooler in temperature, but full of stories to tell.
I like that analogy. And speaking of stories, Arcturus is believed to have originated from a dwarf galaxy that merged with our Milky Way billions of years ago.
Wow, talk about a long history. All right, let's move on to a star that's definitely a household name, Vega.
Vega is another bright star that's relatively close to Earth, about 25 light years away.
And I think it was even our North Star at some point, wasn't it? Like a long time ago.
That's right. Earth's axis wobbles slowly over time, which means our North Star changes. But Vega will be back in the spotlight in about 12,000 years.
Talk about a long game. So what else makes Vega so special? I feel like it pops up in a lot of science fiction.
It's a popular one, and astronomers use Vega as a standard candle. to help understand other stars.
Okay, hold on. Standard candle. Is that some kind of astronomy pun I'm missing?
Not a pun, but a useful tool. Vega's brightness is very consistent, so we can use it as a reference point to compare with other stars. Like if you were trying to judge the brightness of a streetlight far away, you could compare it to one that you're standing right next to.
Ah, that makes sense. So Vega's like the cosmic measuring stick for brightness. Very cool. Okay, what's next on our stellar tour? Don't leave me hanging. We've still got more stars to explore, right?
Oh, absolutely. Get ready for Capella, number 6 on our list. It's a bit of a trickster star.
A trickster. How so?
Well, to the naked eye, Capella looks like a single star shining with this beautiful golden light. But it's actually 4 stars in a complex dance.
Wait, 4 stars disguised as 1. I'm going to need a little more explanation on this one. How can we only see 1 if there are 4?
It's all about proximity. 2 of the stars in the Capella system are yellow giants, think bigger and brighter than our sun. And they're so close together that, from our perspective here on Earth, they blend into one.
Ah, so it's like they're doing a cosmic waltz so closely that we just see a blur of golden light. Okay, but what about the other 2 stars? Are they just hiding in the background?
They're a bit farther out, orbiting the central pair, and they're red dwarfs, so much smaller and dimmer. Imagine if you were on a planet in that system, you might have 2 suns close by and then 2 more distant reddish ones off in the distance.
Wow, talk about a view. Okay, moving on to star number 7, we got Rigel. And this one's a heavy hitter, right? I mean, it's part of Orion's belt, one of the most recognizable constellations in the sky.
You're right, Rigel is hard to miss. It's a blue supergiant, which means it's burning incredibly hot and bright.
So when you say supergiant, just how big are we talking?
Let's put it this way. If you were to replace our sun with Rigel, it would engulf Mercury, Venus, Earth, and even Mars.
Whoa. Okay, that definitely puts things into perspective. And I remember we talked about Betelgeuse earlier, also in Orion, as a star that's going supernova. But if Rigel is even bigger and brighter, what's going to happen when it reaches the end of its life?
Oh, it's going to be a spectacular supernova. When Rigel eventually explodes, it's going to be a cosmic event for the ages.
So a fitting end for such a massive star. Okay, next on our list is Procyon, another star that's relatively close to home, right?
Yes, Procyon is just about 11 light years away, which makes it one of our nearest stellar neighbors. It's also a binary system, with the main sequence star similar to our sun, and a white dwarf companion.
Another binary. It seems like they're all the rage in the cosmos. But you mentioned Procyon's main star is similar to our sun. Does that mean looking at Procyon is like getting a glimpse into our sun's future?
In a way, yes. Procyon A, the main star, is a bit older and more evolved than our sun. So by studying it, we can get a better understanding of what our own star might be like in a few billion years.
Okay, so Procyon's like a sneak peek into the next chapter of our sun's life. Fascinating stuff. But I have to admit, after talking about supergiants and supernovae, I'm curious, what's it going to be like when our sun eventually goes?
Well, it won't be quite as dramatic as a supernova. Our sun isn't massive enough for that, but it will still be a pretty significant event for our little corner of the galaxy.
Okay, you've piqued my interest. Walk me through it. What's our sun's eventual fate?
Well, in about 5 billion years or so, our sun will start to run out of hydrogen fuel in its core. And that's when things will start to change.
I'm already nervous. What happens then?
The sun will start to expand, becoming a red giant. It will actually grow so large that it will engulf Mercury and Venus.
Wait, engulf them? Like, gone?
Yep. And Earth might be swallowed up too, or might just get pushed out into a wider orbit. But either way, it's not looking good for life as we know it.
Okay, that's officially terrifying, but also kind of amazing.
Mm-hmm.
So our sun goes red giant, swallows a few planets, and then what?
Eventually, after its red giant phase, the sun will shed its outer layers, forming a beautiful planetary nebula. And at the center of that nebula, you'll find what's left of our sun, a small, dense white dwarf.
So from giant star to tiny white dwarf. That's quite the transformation. It really highlights how dynamic and ever-changing the universe is. All right, what's our next stop on this stellar journey? Who's next on the list?
All right, 2 more stars left on our celestial tour. What's next? Let's talk about Achernar, star number 9 on our list, and a bit of a cosmic oddball.
Oddball, huh? I'm intrigued. What makes Achernar so unique?
It's all about its spin. Achernar is rotating so fast that it's actually been flattened at its poles.
Hold on, a flattened star. I've never heard of that. How is that even possible?
Stars are giant balls of gas, right? So when they spin really, really fast, the centrifugal force can actually cause them to bulge at the equator and flatten at the poles.
Okay, that makes sense, I guess. But how fast are we talking here? Like, is it noticeable?
Ekrnar is spinning hundreds of times faster than our sun. It's spinning so fast that it's one of the flattest stars we've ever observed.
Wow, that's incredible. And to think we just see a twinkling point of light. It's amazing to think about the forces at play out there in the universe. Okay, we've covered 9 of the 10 brightest stars visible from Earth. So who's our grand finale?
Let's wrap things up with a star that needs no introduction, especially for those of us in the northern hemisphere. I'm talking about Betelgeuse.
Betelgeuse, the red supergiant in Orion. You know, I was starting to wonder when we'd get to this one. It's been in the news a lot lately, what with its impending supernova and all.
It's definitely a star that captures the imagination. Betelgeuse is what we call a ring supergiant, which means it's nearing the end of its life.
And when it goes, it's going to be one heck of a show. Astronomers are predicting it'll be a supernova so bright we might even see it during the day. But on a less explosive note, what else makes Betelgeuse so interesting to study?
Well, apart from its size, and it truly is enormous, Betelgeuse is fascinating because it's a pulsating star.
Okay, hold on. Pulsating, you've officially lost me.
It means that Betelgeuse's brightness fluctuates over time. It's like it's breathing, expanding, and contracting, which causes its luminosity to change.
So every time we look at Betelgeuse, it could be slightly brighter or dimmer than the time before.
It's like it's putting on a little light show for us.
Very cool. Well, we've covered a lot of ground tonight, from binary star systems to white dwarfs, supergiants, and even a star that's about to go supernova. What are some of the key takeaways you hope listeners will remember from our deep dive into the top 10 brightest stars?
I think the biggest takeaway is that stars are far from static points of light. They're dynamic, evolving entities with their own unique stories to tell. And by studying them, by observing their brightness, their colors, even their movements, we can learn so much about the universe we live in.
Absolutely. I know I've learned a ton. It's amazing to think that just by looking up at the night sky, we can witness the life cycles of stars, from their fiery births to their often spectacular deaths. And who knows what new discoveries await us out there in the vastness of space.
That's the beauty of astronomy. There's always something new to discover.
That's so true. Well, on that note, I think it's time for us to wrap up this stellar episode. Thanks for joining us on our deep dive into the top 10 brightest stars. Until next time, keep looking up.